Welcome into Rig Recon University. In this episode of Rig Recon University, we are going to cover flow meters, the technology behind them, and where they are used on the apparatus. Out with our core values here at Clariance, and that is our clear initiative. That is the fact that we have curiosity in what goes on in the industry. We like to provide leadership and base everything around that with an enthusiasm for the products that we have and for the industry we work in. Accountability is probably the key here. We want to be accountable for the products we produce and make sure that you have confidence behind the people behind it and that respect. We want to earn your respect that we're giving you the right product. This presentation is hosted by Rig Recon, stored on our website, rigrecon.com. Rig Recon is designed to be an educational site for you to learn about everything apparatus related. I want to remind you that we have our Rig Recon Live podcast series. We are in season 2. We are wrapping up season 2 right now. On the screen at the time of production here, there were 14 released. I believe we're now up to at least 16 released for season 2. What we're here to talk about today is an education on flow meters. And the first thing that we're going to want to differentiate is the fact that there are two different types of flow meters. There's your portable and your fixed. Your portable flow meter is typically used for flow testing or standpipe operations. So this is where we do something like the Elkhart Brass Know Your Flow classes. So we're coming out in the field. We're going to go over the flow on each line on a rig. We hook up a portable flow meter. We calibrate it, prove that it's working properly, and then go through each discharge and help you define what pump discharge pressures give you a certain flow on that line. We're not going to cover portable flow meters today in this class. There are several brass tacks hard facts videos out there on how to set it up, how to calibrate it, and the benefits it brings to you. So you could watch those if you're interested. Just search brass tacks hard facts and you'll find videos on that. What we are going to cover today are the fixed flow meters. These are installed in the apparatus, typically on a dedicated discharge. They could be on multiple discharges. They could be one on a manifold, and we'll talk about how or why you would do different things there. One key, all flow meters should at a minimum be verified that they're operating properly. Now, I say here all flow meters should be calibrated. What it really means is you first need to check to see that it's flowing the correct amount. If it comes up okay, then there's no need to calibrate it. But you at least want to do the check to make sure it's flowing properly. And then if you need to, you can calibrate it. When we say checked, what we mean is set up a known line, deploy a section of hose, put a smoothbore nozzle on it, and pitot that nozzle. Depending on the tip, let's say, for example, it's a 7/8 inch tip. If I have 50 PSI on that 7/8 inch tip, the laws of physics say that that's 160 gallons per minute coming out of the end of that. Then check the flow meter on that line to see that it says it's 160 gallons per minute. If it doesn't, you have options on how to calibrate it. Where are flow meters used? Well, majority of flow meter use in the industry is on a foam system. Any direct injection foam system has to have some type of flow calculation to know how much foam to inject. That is typically done through a flow meter. There are a few foam systems, like if you're using an eductor or you're using an around the pump system, that works off an eductor principle as well. That doesn't necessarily have a flow meter. That is using the Venturi principle and then a ratio adjuster for how much foam's going in. But on most injection systems, we're using a flow meter to calculate how much water is going through so we know how much foam to inject. There is no overarching code that says that you have to put a flow meter on a fire truck with one exception, an aerial with a pump and a waterway. You have an aerial with a pump and a pre-piped waterway, you are required by section 20.14.8 of the NFPA code to have a flow meter installed there. Let's talk about the types of technologies. There's a couple different technologies on the market. You're going to find that we don't use very many different technologies in our industry, but I'm going to explain what is at least out there so you have an understanding. The first is electromagnetic detection. Electromagnetic detection's really big benefit is there's no moving parts. And the way electromagnetic detection works is You have a clamp around a pipe that creates a magnetic field. When you create that magnetic field, there are impurities or particulates in water. And as those particulates flow through the magnetic field, they're going to generate a little bit of a voltage, which is then measured at the next point of the pipe. Now, don't hear voltage and think, so we're electrifying the water. Not at all. It's the movement through the field that generates this voltage that is very minimal. But then if we want to get into a deep dive on physics, Faraday's law is a calculation you can do that relates voltage to flow. That gives us our flow meter. This is very popular in industrial applications, not used at all in a fixed application on a fire apparatus. The reason is it requires a very long run of straight pipe. We're going to talk about different flows and straight runs of pipe. You have to have a very long straight run of pipe, and it's very susceptible to turbulence. We're going to talk about turbulence a lot as we go through here. When I mention turbulence, just think of your handline nozzle with a smooth bore. If I've got that smooth bore open the whole way, that's a little ball in there that's controlling that, I get a nice solid stream coming out. If I crack that smooth bore nozzle back some, so I gate the valve or the ball, I now get chatter in the line. The stream coming out doesn't look that great. That's your turbulence. Another system would be conductivity sensors. Now, conductivity sensors wouldn't work for just straight water because you need to change the conductivity of the water. These were being used in foam systems for a short amount of time as a test method. Concept here is there's no moving parts. I inject foam into the system, and when I inject foam into the line, it changes the conductivity of the water. So on the left side where you see the arrow, I've got a conductivity sensor that's measuring the water conductivity. Then I inject foam in the next portion of the pipe, and I have another sensor on the right that detects what the conductivity is now with the foam in it. I can do calculations that tell me what the percentage of foam is based on the change in conductivity. This would give me a very accurate injection rate. It never really did catch on as a durable technology. The systems that had it also had a paddle wheel installed just to be safe, and they kind of ended up doing away with the conductivity sensor. So this isn't something we see very often in our industry. Paddle wheel is our most popular technology. It's been around forever, and it is what we use. It's a spinning wheel that measures the flow of the water. So you see that there's a housing and a sensor that's stuck down into the pipe. It only goes into the very edge of the pipe, so it really doesn't disrupt your flow that much. As the water goes by, it pushes that wheel that turns. That wheel generates a small voltage that goes up through the wire, and then we can calculate what our flow is. Next, we're going to talk about product installation. Product installation is really the core part of what goes into a flow meter. And the unfortunate thing is, from an end user, I'm going to educate you on the installation, and you may be watching and going, well, I don't install these things. Why do I care? Well, that's true. You don't do the installation. But when you spec a fire truck, you give guidelines to an OEM. So you want to know what goes into the installation so that you can make sure they're doing it the right way. And then when you inspect the truck, you can look at it. So the first thing is there's several ways to put this flow meter into the pipe. On the left, you see a saddle clamp. So I'd be drilling a hole into a pipe, and then I use this saddle clamp to clamp this around the pipe, screw the flow meter into the top of it. In every one of these examples, the flow meter is always very accessible because the large brass nut you see on top, you turn that off and you can pull the flow meter out of the pipe. You, of course, want to do this when the plumbing's not charged. And if there is water in the pipe, you are going to get some water out of it when you pull that out. That brass nut, this is just a little side note, that should be hand tight and that will not leak. You should not be putting a wrench down and clamping that brass nut down because you can end up sandwiching the flow meter in there and damaging it. You really want that only hand tight. Second fitting you see is a weld fitting. So they would drill a hole in the pipe, weld that silver piece in, and then put the brass piece insert in. A pipe T would be you're cutting off two pieces of pipe, sliding a pipe T in the middle. One option that we do sell on the Elkhart valves is the option to integrate the paddle wheel into the valve configuration. So where you see our discharge fitting or our intake on the discharge side of the valve, you can put that end cap in there and slide the flow meter right into it. Now you see I have noted there fire pump on left, discharge valve on the right. We're going to talk about where you want the flow meter in the plumbing. You want it before the valve if possible. It's not always possible, but if possible, you want it before the valve because of the turbulence that happens when you gate the valve, which is what we talked about with the handline nozzle. The whole key here is we're trying to create laminar flow. Laminar flow means a nice, smooth, even flow. Turbulence is the enemy. So when I talked about gating a handline nozzle, you get the chatter and you get that broken water stream, that's your turbulent flow. It's going to cause your flow meter to bounce back and forth and give you wild readings. The charts you see down below are what the flow meter outputs. So when it sees a nice laminar flow, we get a nice even voltage coming out, and we can display a great flow for you on the screen. When I get that turbulent flow, the flow meter bounces, the paddle wheel moves back and forth, and I get that jittery line. That's voltages coming out that are all over that are going to cause your output on your flow meter to be 130, 160, 120. They jump all around. So turbulence is that enemy. Now, this all sounds simple, and you just say, well, why doesn't my OEM just follow the guidelines and put the right size pipe in? Space is a very valuable commodity inside that pump house. There's a lot going on in there. There's rods for the valves. There's all kinds of piping and plumbing in there. We have to be able to drain it all down properly. And we don't want a 90-inch wide pump house. Everything we do on a fire apparatus costs, and I don't just mean in a dollars sense. I mean that you have to give something up. So if I add a whole bunch of flow meters, yeah, it's going to cost me money. It's also going to cost me space. It's going to make my pump house wider. Or if I want to keep my wheelbase down, I'm going to have to shrink the body. You got to consider vehicle overall length and turning radius of a vehicle. So we are always trying to do the proverbial stuff 10 pounds of things into a 5-pound sack, and it doesn't always work out. Just want you to understand why we give these guidelines, but why sometimes they're not followed, because there were other factors that came into play. When we talk about installations, the first one would be mounting it after a valve. This is the worst case scenario, because if I mount it right after a valve, I have to go 14 times the diameter of the pipe away from the valve. What that means is if I have a 2.5-inch pipe, I have to be 35 inches away. Our average pump house is internally about 70 inches across between the panels. That's a lot of space to get 35 inches away. Our average length of a pump house is anywhere from, heck, on a mini pumper, it's like 28 inches wide. On a big full-size pumper, a lot of times we start out at 40, 46 is a popular size, 52 with the growing pump houses these days. You really don't want to get over that 60-inch length because now you're really adding a lot of wheelbase. If I go after an elbow in the piping, I have to go 6 times the diameter away from that elbow. So now I'm at 15 inches away from an elbow. If I do a pipe reduction, so let's say I have a 2.5-inch pipe, and then I'm going to reduce it down to 1.5 inches for a flex hose that's going out to the front bumper, maybe for a bumper monitor. Then I only need to be 2 times the pipe diameter. So I only need to be 3 inches away from that reduction area. The most ideal spot is before the valve. When I go before the valve, I only have to be 1 time the pipe diameter. That's where you saw that fitting on the discharge valve that integrates it in. That's going to set it up on its own, a 2.5-inch pipe, 2.5 inches back from that valve. One option that we do offer to help is called a flow conditioner. Flow conditioner is a piece of brass that sits down inside and has 3 holes in it. You can see it on the screen here, and it creates that laminar flow. That keeps the chatter out of our flow meter, out of our paddle wheel. I mentioned it's an option. It is truly an option. If you want this, you need to specify it. I would not recommend doing any flow meters without a flow conditioner. And I'm not just a salesman here. It's going to give you better readings. Now, when you do get into the flow meter technologies, when you want to compare different flow meters on the market, you want to look at how they get calibrated, because there's a difference in between accuracy, preciseness, or both. Sure, I want my readings to be consistent, but I also want them to be consistently correct. The way we calibrate a flow meter is we put a known flow onto that flow meter. So in the example I gave earlier, we set up a hand line, we put a smoothbore nozzle on it. Let's say it's a 7/8 inch tip, and we put 50 PSI at the tip. There's calculators out there. Some of the tips have it engraved into it. The laws of physics tell us that 50 PSI going through a 7/8 inch opening is going to give us 160 gallons per minute. That paddle wheel is now spinning, and it's putting out a voltage. And what we do is when we calibrate the flow meter, we tell it right now what you see going through there, that voltage is equal to 160 gallons per minute. The logic inside the flow meter then creates a linear relationship that says, okay, well, if the voltage goes up, the flow is going up. If the voltage goes down, the flow is going down. That works. There is, however, inherent inaccuracy as you move away from the calibration point. I'm going to blow this chart up for you. So if I calibrate it at 150 GPM, when I'm flowing 150 GPM, that flow meter is going to be right dead on accurate. As I move away from that 150 GPM, I go up to 200 GPM, 250. I have a linear relationship, but I'm going to get a little more error built into it. I get all the way out to 300 GPM, I'm going to be off by a certain factor because of the way the flow meters work. One of the benefits that we give you with the FRC flow meters is we can do multi-point calibration. So I can set up that 7/8 inch tip, and I can flow it at 50 PSI and calibrate to 160 GPM. Then I could drop it down to 40 PSI, plug it into a calculator, see what the GPM is supposed to be, and calibrate at that point. I could kick it up to 70 PSI. I could change the tip out and put a 15/16 tip on there. And now at 50 PSI, I'm flowing 185 gallons per minute. I can calibrate up to 10 points on an FRC flow meter. What that does for me is it gives me a very accurate flow all across the range of flows that I'm going to go through. And that's the important differentiator. That's not available on every flow meter in the market. I'm going to quickly walk you through what's available in the FRC product family so you understand what's out there available to you. We call all of our flow meters the Insight family. So we've got the Insight Ultimate, the Insight, and the Insight Plus, and I'll walk through each one individually here for you quickly. All of the Insight family of flow meters are programmable through the front face of the gauge with a magnet. What that means is I don't have to disassemble things to do the calibration. There's a series of touching a magnet on the front face of it, and I walk through it. And we have videos online that show you how to do that. We do have NFPA colored bezels available for easy identification of the valve. They have a day-night mode sensor built in so that they can increase and decrease the brightness. I mentioned already you can calibrate them at up to 10 flow points. They all have a totalizer functionality built into them, so you can see the total flow. Now, when you turn power off, that resets, but you can at least see the total flow you flowed through that line on the fire. And then our data link allows us to do remote displays. So if we had 5 flow meters and we wanted to total them all up with one gauge, we could do that through our system. Insight is the entry level, the first product. The reason I say it's the entry level, it only shows you flow. It's going to be digital flow for that specific discharge that it's installed in the pipe on. Has the built-in totalizer function, does have remote display capability. So in that aerial application where we said The code says you need to either show it on the pump operator's panel or the aerial operator's panel. Through a simple cable 2-wire connection, you could show it in both if you needed to. Insight Plus gives you the added benefit that you can show pressure or flow. You'll see there's a pressure flow selection button there. You decide what you're displaying on the screen. Insight Ultimate is the best of both worlds. It gives you that traditional analog pressure feel with a needle, and then it gives you a digital flow that you see all the time. If you're going to do a totalizer on this one, you're going to need to have an external button installed to see the total. And then we give you that expanded range of your common flows. So if you're in that 300 to 600 PSI, that's kind of rare. That's a smaller scale. But that 100 to 250, where we operate every day on an operating hand line, that's blown up for you. We're going to wrap up by talking very quickly about our competition, like we do with most of our Rig Recon University classes. Our competitor here on a fixed system is going to be IDEX Fire and Safety, otherwise known as Class 1 or Hale. They do a digital Flowminder is what they call theirs. You can see on the left the digital version of it. On the right, you can see they do have a dual version like our Insight Ultimate, but they're basically two separate pieces. It's their traditional pressure gauge and then the digital Flowminder display built into the bottom of it. When I compare these products operationally, there is no expanding scale on theirs. It is their simple old analog display and then the digital pressure below it. Very similar installation instructions. Their distances are similar to ours. I think we recommend 14 times the diameter of the pipe after a valve. I think they might recommend 15 times. It's very close. They don't recommend installing it after a pipe reduction. We've done testing. We know you can do it after a pipe reduction. The big one is Class 1 only has single point calibration. They don't offer a multi-point calibration. So when I showed you that chart that showed how you get, when you get further away from your calibration point, you're going to have more inaccuracy. That's inherent to all products. That's just inherent to the way a flow meter works. And they're only giving you the ability to calibrate at that one point. We both offer the totalizer function. That wraps up our Rig Recon University on flow meters. Hopefully you got the information you needed out of that. If you watch this and there's something more you wanted to see or there's something you don't know, you can see my contact information on the screen there. If you scan that QR code, it will connect you to me directly. My email address is my first name dot last name at safely.net. And I would love to hear from you and connect with you if there's anything I can help you with. Thanks for tuning in to Rig Recon University and look forward to seeing you on a future broadcast.